Okay guys, today we're doing 5.1, equation of a tangent line or a normal line. Okay, we're doing both of these, tangent lines and normal lines. I hope tangent line brings something to your brain like the word derivative, because remember, derivative is a tangent line. Okay, let's go forward here. Okay, warm up. If a linear function, we're going to call it f of x, passes through the points 1, 2, and 4, 6, what is the derivative at 1? Okay, well, first off, it's a linear function, right? And this is a type of question they might ask on the test because it seems difficult, but if you read through it, it's very easy. It says it's a linear function. Okay, we know linear functions means that it's just a straight line, right? And it goes through the points 1, 2, 1, 2. So we have a point right there, and the point's 4, 6. 4, 6. Okay, a linear function just looks like this, right? Okay, well, the derivative everywhere is the same since it's a linear function. So if it asks you what's the derivative of this, if it goes through both of these points, all you need to do is find the slope of this line. Well, the slope of the line should just go back to our olden days, y2 minus y1 all over x2 minus x1. Okay, and that would be, in this case, 6 minus 2 all over 4 minus 1. And that would give us 4 over 3. And that would be the slope of the line, right? And that's the derivative at 1, because the slope everywhere is 4 over 3. So that's the derivative at 1. It's the derivative at 2. It's the derivative at any point you want to put in there. The derivative at c, right? That's the derivative of the function is 4 over 3. Okay, so we're going to be doing something very similar to that today. So, let me go back. Okay, so derivative gives the slope of a tangent line at any point. So what we're doing is, let's say this black function here. This is our original function. We'll call it f of x. Yeah. So this is some function f of x. This line that's tangent to it, that's the derivative of it at some point, which looks like the derivative at about -1 in this case. Yeah, that's the derivative at -1. What we're going to be doing today is, instead of just finding the slope of the line, that's what we've been doing for the past 3 chapters, we're going to actually find the equation of that line. And that's not anything difficult, right? Because if you know the slope, you have multiple ways of finding the equation of a tangent line. You know this one from back in algebra, and then we're not going to use this one, but you know that one. You could use that one if you want to. That's slope, and that's your y-intercept. The one I like to use is point slope form, which is y minus y1 equals mx minus x1. And I hope you remember using that in Algebra 1 as well. That's a point slope form, and we're going to be using this equation here to find the equation of this tangent line that we have here. So let's give this a try. Okay, so whenever you see the words write the equation, find the equation, anything like that, you're going to be writing that out, the point slope form. And you're just going to be filling it in. They need to give you at least one of these 3 things, okay? They need to give you the y, they need to give you the x, or they need to give you the slope, okay? And then from those things, you can find the other ones that aren't given. But those are the 3 things we're going to be filling in. Is the y, the x, and the slope. The y and the x here, those are parts of the equation, so we're not going to be filling those in. So let's give it a try here. Write the equation of the tangent line of the function at 4. Okay, so that means saying write the equation of a tangent line, that's the derivative, right? The derivative of something at 4. So we're going to be writing the equation of some line of the derivative at 4. Okay, we're going to be using this function right here. So remember, when I said whenever you see that word write the equation, it's asking you to write an equation out, you're going to be writing y minus y1 equals mx minus x1. And we're going to be filling in this, this, and this. So let's do that underneath here. We're going to do y minus, I'll leave it blank, equals m, I'll leave blank, x minus blank. Okay, we're filling in these 3 things like I just said, okay? So they need to give you at least one of them, okay? They need to give you the y, they need to give you the slope, or they need to give you the x. With one of those, you can find the other one. In this case, if you see it, it says write the equation of the tangent line at x equals 4. Okay, well, it gave us 4. So I already have something I can plug in there. 4. Now I need to find the slope and I need to find the y. Okay, well, to find the y value, that's just going back to algebra 1. If you plug x in 4 into the x value here, you get the y value for that point. So let's do that. 4 minus 3 squared, 4 plus 2. That would give us 4 minus 3 is 1 squared, which is 1. And I'll do 1 squared, times 6. Okay, that's going to give us 6. That's the y value. That is f of 4. That's the y value, right? So 6 goes right there. Now all we need to do is find the slope. After we find the slope, we're pretty much done. We just need to solve for y. Okay, so to find the slope, that's what we've literally been doing since I showed you how to take a derivative. All we need to do is take the derivative of this, and it's going to tell me the slope at 4. So let's first take the derivative of the function. This is going to be product rule, this being one of the functions, that being the other one, and chain rule within it. Okay, so I'm going to rewrite the first one, x minus 3 squared, and then take the derivative of that one, which is going to be 1, plus, okay, rewrite this one, and take the derivative of that one, which would be 2 x minus 3, leave that stuff alone, raised to the 1 power, times the derivative of the inside, which is just 1. Okay, let's kind of clean this up a little bit. Kind of looks ugly right now. So, cleaning it up, 1 times anything leaves us the same, so we got x minus 3 squared, plus, okay, well I got this times that with that. How about I'll just rewrite it as 2, x plus 2, x minus 3. Okay, I can then factor out an x minus 3. Notice we have 2 terms. Yeah? Or you could just plug in 4 at this point and see what it comes out to be. I am going to factor this out just because it's good practice, okay? You don't need to do that on the test if you don't want to. If you think, hey, I'm good to plug in already, go right ahead. You could have plugged in right here if you wanted to. You didn't need to rewrite it or anything. Okay, so I'm going to factor out an x minus 3. Okay, so what's left in this term? I took one of the x minus 3's out, so I have an x minus 3 left. And notice I don't need to write the parentheses anymore because it's only one of them now. Plus, I got a 2 and an x plus 2. Okay, and I took that x minus 3 out, so I don't need to rewrite it. Okay, now what we got here, I can still rewrite it a little bit. This is going to be x minus 3 plus 2x. I'm distributing this 2x plus 4. And I can rewrite it just a little bit more here. I got x minus 3 times, I can combine those to be 3x plus 1. Okay, that's the best form to write this derivative. Okay, that's the derivative of the function, right? This is an equation to find the slopes. Equation to find slope, right? It's not the slope. It's just an equation to find the slope. So if I want to know what the slope is, like I do for now, I'm going to plug 4 into that. So the derivative at 4 would just be, plug in 4 into here, 4 minus 3 times 3 times 4 plus 1. Yeah, and this is going to be 1 times, that would be 12 plus 1, so 13. So the answer is 13. So my slope is 13. Okay, and that is the equation of the tangent line. All you need to do is solve for y. So what I'm going to do, I'm just going to add that 6 over. I don't need to rewrite it in any other way. So my answer will actually be y equals 13 x minus 4 plus 6. That's just me adding the 6 over here onto the right hand side. And that's my equation right there. That's it. I have something on the bottom here. It says write the equation of the normal line of the function at x equals 4. Notice that's basically the same thing it's asking up here. This one was for a tangent line. You just need to know what a normal line is in order to do this new task here. A normal line means perpendicular. And I hope you guys remember what perpendicular is. That's where lines cross each other at a 90-degree angle. That means everything here will be the same except the slope. The slope is going to be at a 90-degree angle. So normal slope, if you guys remember how to make something perpendicular, what you do is you take your slope you have and you flip it. You do the reciprocal, so it would be 1 over 13. And then you do the negative version of it. So it's going to be negative 1 over 13. So that's what a normal is. Perpendicular, that's going to be the slope of a normal one. It's just going to be negative 1 over 13. X minus 4 plus 6. It would be all that same work. You would set up this equation. You would find your x, your y, or your slope, whatever it is that they gave you. In this case, they give us 4, just like they did in the previous one. You would have found y by plugging it into the equation. You would have gotten 6. You would have plugged 6 into there. And then when you did your slope, instead of doing the slope you got from the derivative, you want the perpendicular slope. So you would have just done the reciprocal of it, 1 over the derivative, yeah, at that point, and you would have done the negative version of it. So like let's say your slope would have been, I don't know, negative 5. The perpendicular version of that slope, which we denote by that, would the normal version would be flip it, so it'd be 1 over negative 5, and then you do the negative of it, which would make it positive, so it'd be 1 over 5. Okay, that's just an example. This is the answer to this one, to this question right here. Okay, I got one more slide for you, I believe. Let's see. Yeah, just one more. Find the equation of the tangent line of the function. Now notice it said find the equation of the tangent line. That's where whenever I read that, I am going to go straight to writing y minus y1 equals mx minus x1, right? I'm going to fill in those 3 things so I can just leave blanks on those. Okay. Find the equation of the tangent line of the function this, where the tangent line is parallel to this function right here. Okay, remember they need to give us either the y, the slope, or the x. In this case, they can give us the x or the y. They told us that this function is going to be parallel to this function. Well, if they're parallel, that means they have the parallel means same slope, right? So that means that if I can find the slope of either one of these, then I do know the m, correct? And I hope you already know this, y equals mx plus b. They just gave us this slope. It's right here. It's 4. So they told us the slope is going to be 4. So I do have one of these 3 things, which they will have to give you one of them, okay? In this case, they gave us the slope. Now we need to figure out how to find the x and the y with the slope they gave us. Now, like we said before, slope means derivative, right? That's what we're talking about. So let's take the derivative of this function, which is, this one's a fairly simple one. It's just going to be 2x, yeah? The derivative of negative 3 is 0. Okay, so this is an equation to find the slope wherever you want it. Well, we know the slope is 4. So let's do this. Let's do 2x, the equation that finds slope, set it equal to 4, which is the slope we have, and see when it has a slope of 4. So we divide by 2, and we get x equals 2. Okay, the only time you're going to have a slope of 4 on this graph is when the x value is 2. So now I got my x value. All I need to do is get my y value. Well, all I need to do to get my y value is plug the x into the original function. So f of 2 is going to be 2 squared minus 3, which is going to be 4 minus 3 is 1. That's going to be my y value. I need to solve for y, which just means I just need to add the 1 over. So I got y equals 4x minus 2 plus 1. And that is the equation of my tangent line. Perfect. Now if you wanted to distribute this 4 and add like terms, you're more than welcome to. If it asked you to find the normal line, remember you would just flip that slope, flipping it, and make it negative. And your equation for a normal line would be like this. Yeah? That's for a normal line. But it didn't ask us for a normal line. Don't get confused with that. Okay? But that would have been a normal line. All it asked us was for the equation of a tangent line. And on the test, they're most likely going to ask you about equations to tangent lines, not normal lines, okay? And they're going to ask you to use that tangent line to estimate things, which we'll talk about in the next lesson. That's everything for this one.